Starting. All right, we're back. Hello, all of you lovely online people. I hope you had some coffee or water, if you're not a coffee person, tea. We've got babka here, so you know that's always a good way to go. All right. I am going to go back to the slides, and we're going to continue. What we're going to be talking about now. There we go. So now what we're going to talk about, if I can find it, are the surveys. So we're going to talk about surveys, what they are, how we conduct them. And while we talked about the manipulation this morning, that's definitely something that's in process, whereas the surveys are something that many network nodes have done already. And the surveys are really where we have a data set that you can already begin to use, like right now. And so if you begin contributing to the surveys this year, our data set is going to become embiggened by your contributions immediately. So very briefly, the objectives of the surveys, the experiments are great because the experiments we can say, look, the only thing we're really going to try and let vary is temperature by, and we're going to let temperature vary by looking at different spatial locations. Now we all know that when we think about disturbance, there are a lot of different sources of disturbance, but there's one that's very common within kelp forests across the world, and that's wave exposure. Waves remove kelp in many, many different systems. And that's not true. Yes. We just had some people walk on in. Hey, Tom. Would you like to introduce yourselves to the room?
Yeah, hi everyone. I'm Tom and this is Daniel Jordan, both from the University of Rhode Island.
Woo.
Joining on. Do you have Lindsay? Is Lindsay on the line there?
I believe so, yes.
All right, great.
Yeah, and you're walking in at just the right time. So we spent this morning, we talked, you missed my indoctrination evangelization. So, you know, my indoctrination and evangelization of kelp and network ecology.
Oh, I missed it?
Yeah, you know, you can catch it on.
Does this room need to be indoctrinated?
No. Well, some of these guys are new techs and undergrad, so they didn't, you know, they haven't learned to love the kelp.
Okay, let's see if we can add to that.
Yes. So what we're going to be talking about now is the surveys, which is what you guys have been doing already, and so we'll talk a bit about that and make sure that you're on the same page as us. Then we'll talk a bit about data entry and data, which is like boring, I realize, but especially now that I spent a month going through everybody's data, I'd like to talk about it. We'll also then have break for lunch, and then this afternoon we'll do some live demos out in the ISC and sort of just make sure we all have the physically in our bodies have what we're doing. But I'm really glad you guys can make it.
It's great to see you.
Yeah, it's really good to see you. We're all on the East Coast now. It's crazy.
Yeah.
Anyway, also, we do have this online, so if I sometimes lean in strangely to my laptop, it's because I'm talking here. Anyway, so the central objectives of this are to look across a wide range of variability of environmental covariates and really try and think about wave exposure. So, you know, if we think about different years having different degrees of wave exposure, to what extent can we start to think about temperature interacting with wave exposure to change both kelp abundance as well as whole communities? And really do ask about whole communities. So the idea of the surveying is to look at whole communities. And so here's sort of the model that came out of that NCEAS working group that I was telling you about. And it's a fairly sort of general model. It may look familiar to some of you. And the idea is that if we think about a given ecoregion and the kelps within that ecoregion, that the temperature relative to the thermal limit of those kelps and the amount of wave disturbance as experienced by those kelps may well interact, so that you may experience greater or lesser kelp loss depending on the relative levels of the two. In other words, waves have a bigger impact, disturbance has a bigger impact when temperatures are warmer. So for example, like a big wave event in the Narragansett or outside of Rhode Island might end up impacting kelp forests more than a big wave event, say out at like Appledore Island or something like that. And that's because it's just warmer there, and so kelps may not have as much recovery capability. Maybe, I don't know, that's why we're doing this. There's a lot of controversy about that. And so that then may translate either directly or indirectly to community structure in the various ways we measure it. Maybe that's the abundance of individual species Maybe that's something like species richness. Maybe it's some other aggregate community property. There are a lot of ways to look at that. So this is the sort of general path model that we came up with this at the meeting. There are a lot of different ways to address it. And hopefully we can begin to start doing that here soon. So this is, since here in this room we are all from Keen 1, this is Keen 1 so far. This is a map of all of the sites that we've surveyed so far, or actually we're missing one, and the labs that have contributed so far. So far the data set that we have, and if you're interested in this data set, I'll show a little bit of it, but I gave a longer presentation about it yesterday, which you can also find on the Keen website or just on YouTube. We have sites from our lab, from the Grabowski lab at Northeastern, as well as Marissa McMahon leading some stuff a little bit further up in Damariscotta, from Jen Dijkstra's lab at UNH, and from the Humphreys lab down at URI. So thank you everyone who's contributed so far. And then this year, Doug Rasher and Nicole Price up at Bigelow are going to set up a site there in collaboration with Hugh Suskowitz. And so we'll have a Keen site there as well. So we really are like from Rhode Island all the way to down East Maine. We're going to have a fabulous gradient. And hopefully we do have some of you from Yukon who are on this hangout as well. If we could get stuff going up at Long Island Sound as well, that would just, it would be mind-blowing in terms of the range of temperatures we'd have. And if we really can keep this up and running over a couple of years, really trying to think about regional change. So I'm super excited. In terms of standardization of these monitoring sites, the idea is that near zero, you should be on some sort of a rocky reef that's not an urchin barren. So we want to actually start in rocky reefs. The transects within these sites should be placed in a stratified random manner every year, and I'll talk about this in a minute. This is somewhat analogous to what they're doing in the PISCO protocols, and one reason why we can make the PISCO data play nicely with ours. And that we're sampling at the peak sort of growth and abundance season, typically midsummer. So one of the reasons that we're having this meeting now is we're about to all go out in the next month or two and do our observational sampling. And so I want to freshen everybody's minds. So we're really in that period of time when now is the great time to do that sampling. Everything's going. So just to walk you through how you set up a single site for those of you that haven't done this before or have questions about this. Let's say this is a landmass with a rocky reef around it. The first thing to ask is, where's the water depth between about 8 and 12 meters? Or actually for some sites further up in Canada, given the limits on zonation there, we've actually pushed this up to 5 to 12 meters. Where is there kelp? And again, by where's there kelp, I don't mean like my region has no kelp in it or has very sparse beds. No, really, within the area that you're working, where is there what is a reasonable sort of ambient abundance of kelp? So again, I know in some discussions about Long Island, there's not nearly as much kelp there. That's fine. What is something that is truly representative of the kelp beds and kelp forests within your region? That's what we're really looking for here. Excuse me. For each of those, divide a single quote-unquote site into 4 different areas. So choose 4 areas, and then within each area or each strata, choose a point randomly. And the reason we're doing this is that then you come back in the next year, same site, divide it up into 4 areas, choose 4 new random points. We went back and forth in terms of thinking about laying down permanent transects, but I think permanent transects, the agreement we came to is that actually laying out, maintaining permanent transects across all networks nodes was going to be hellacious. You know, this is a decision, for example, that PISCO made a while ago with some very good reasoning behind it to make the sampling program lightweight, flexible. And if we really are trying to think about spatially spreading across a wide region, we're interested in how individual sites are changing over time, not necessarily individual transects. That, and this really does make lives easier for all of us every year. So lightweight. So 4 randomly chosen places, 4 transects per site per year. Within each site, we ask that you put down 2 temperature loggers. So we've been using hobo pendant loggers. And we've got a design that's in the handbook of a nice little hardened capsule, so it's fairly easy to deploy them. We've lost a few over time, but in general, by putting down 2 per site, we've had very minimal loss of these loggers. And we found this is a pretty robust design, even to lobstermen dragging their pots over areas. Although sometimes the lobstermen always win. Not always. It's a good design, though. In terms of wave exposure for these sites, right now we're using modeled values from WaveWatch 3, so that's publicly accessible data. This isn't perfect. It provides sort of a relative measure of offshore wave exposure for these sites. There's nothing really good that tells you on-site wave exposure from a geospatial product like that. Well, we can talk about this more at lunch or in the future, but one thing we've been doing in our lab, and we're hoping to put into some future proposals so we can spread these to you guys, is developing a low-cost wave pressure sensor. And so that's in the future, but we're not quite there yet. But hopefully that's something we'll be able to do so we can begin collecting that data ourselves. As the goal there is cheap, easily replaceable, like a pendant logger, but something so we can actually get on-site wave exposure. And then we have sort of a sampling design that's a gamish of multiple different sampling methods. These are derived from a couple of different programs, the SBC-LTR, PISCO, in both New Zealand and Australia's MPA monitoring and protocols. And so we're going to walk through this piece by piece, but the central sort of core idea is that we have 4 40-meter transects with a combination of different techniques to assess abundances. I'm really actually going to, I will cop to the fact that like 80% of this is really based on the SBC-LTER protocol. So that's Dan Reed there, who runs the Santa Barbara Coastal LTER. A lot of thanks to them for providing a lot of the initial materials that we've been able to put together into a handbook. But we've also brought in elements of other sampling programs because we all are in different systems. We all have different needs. And SBC has some very particular ways that they do things for that particular program. The reason we've done this also is so that our data can be compatible with other sampling schemes from other regions. So if you're listening to this or new to the network and have your own sampling program already, that's great. I think as long as we calibrate against 1 year of your sampling so we can make those translations, we should be able to fold your data in with ours so that we can have a much larger data set we can all share and use together. So briefly, I'm going to walk through each of the different techniques and talk about them a little bit. We will practice all of these out in the atrium later this afternoon. So we've got quads and transect tapes ready to go. And I'll talk about this a bit at the end because we'll take a look at the data sheets as well. We also have a suggested practice dive that you should all do before you actually start sampling. And so we have a practice data sheet as well. Our fish sampling is fairly straightforward. Basically, the idea is as the transect gets rolled out, a diver leads the way and swims a fish transect, sampling 1 meter on either side. That's for Keen 1. I know that some of the other regional networks, and there is discretion by the regional coordinator from place to place, have different widths depending on the way sampling programs work in that region. So I know, for example, in Australia, it is a wider transect, and that's because that's what works with that particular system. Here we've been trying to conceptualize it as 1 meter on either side and roughly 2 meters or a little bit more above. And the idea is to count all of the fish that are off the benthos. So really trying to think about who is present. Fish are then recorded in size bins, and we also record young of the year. So pause. Any questions about that?
Why?
Young of the year, so the little guys. Sometimes there are a lot of these, sometimes none. Quadrat sampling is primarily for larger organisms that are not terribly rare and that we can really count as individuals. We place 6 1 square meter quadrats along the transect line, evenly spaced, flipping sides each time, so 0, 8, 16, 24, 32, and 40 meters, and alternating signs, onshore, offshore, inshore, offshore. This really is for large solitary algae, larger invertebrates, and small cryptic fish. We'll pull up the data sheets in a minute so we can actually go over what those are for those of you that are working in New England, so you can kind of ask questions about that and make sure there are specific sort of concerns. But yeah, that's an individual thing. I can count it, and it's common enough that I'm not likely to miss it if I'm only sampling 6 1 square meter. So for example, we began, there are some things you'll see that we sample both using this and other protocols, and that's because I actually don't have a good sense in New England for some of these species as to what's going to be the most accurate way to count them. Yeah, some things are rarer than they used to be. Yeah, there are many mobile species included in here. Urchins are sort of the primary one. They're big, they're solitary, or small for the juveniles and easy to count. We do include stars in these, although stars are mixed because for whatever reason, stars seem to have died off in New England about a decade ago, and they're pretty rare now, even though they used to be quite common. And I think we still count cryptic fish in here, but we count cryptic fish both in quads and swaths because, again, not totally sure what the right method is going to be for these guys. That's an analysis for down the line. Also, if you see rabbits, definitely count those because that would be weird. Swath sampling is for things that we can count as individuals but are a bit rarer or are clumped, and so we're likely to miss them in quadrats. So there are a number of different algae, for example, that you'll find like one clump in a 100 square meter area. And so you're much more likely to pick that up in swath sampling than you are in quadrat sampling. So these are for large, rare, clumped solitary species. Also larger demersal fish, which are generally a bit more rare. And so we'll go over the data sheet in a minute. You can kind of take a look at that, ask questions, and see what I mean. Again, there's currently some overlap with quadrats. Some point, well, now that the data is all together, in the next year or two, we can take a look at that and decide what, whether they're getting roughly the same results or if one is undercounting abundances. And if they're not undercounting, we'll just move it to one protocol and not worry about it on both. But for now, you'll see there are some things that are on both. So 20, nice. In thinking about dive organization, the way that we typically do this is one person rolls the transect tape out with the second person doing the fish count. As they get to the end of the transect, they'll turn around and each of them will take a swath sheet. So one diver does one side, the other diver does the other side. And then they'll swim back along the transect and do those swaths, or they could move to the beginning and swim out. Either way. And the reason that that works is that way you're able to maintain a buddy pair at all times, so good, safe diving practices. And it seems to have timed out relatively well in terms of the times it takes to search for some of these more cryptic organisms along swaths. Ted, do you have a comment?
Yeah, to my own preference, I generally, when we're doing fish counts, I swim the tape out myself because it allows me to then count as I'm going and sort of keep a straight line. And the buddy sort of stays back a little bit so that you're not disturbing fish ahead of you.
That's what we did.
Yeah.
Austin would swim the tape out.
Count fish. Yeah. Either way, whoever is person in front, whether they have the tape or don't have the tape. Yeah. We're also experimenting this year. We talked a few years ago about trying to use GoPros for fish sampling. So put them down for a while, let them soak, and then count fish so that things are fairly undisturbed. So Felicia is an REU in my lab, and this year she's doing some stuff with looking at predation, but part of that is to put GoPros on these traps and see if we can get that to work. And we're actually pairing that, what she's doing, with the keen sites that we're doing. And so if it all works, and if we see that GoPros provide either a more accurate method, then we may just switch over to those, which is great, because that's one less thing to do. The last thing, and perhaps one of the more difficult things to do, I'll say, since I usually end up doing it, so I'll complain, is uniform point counts. So for quads and swaths, and fish counts, that's a closed species list, so these are the species we look at. Obviously, there's going to be variation from place to place. So for example, in Rhode Island, there may be some species that we just don't see here. And so they should be included in quads or swaths, but we just don't see them. Yeah, so uniform point counts are an open species list. So we have an open species list. So I noticed, for example, in Rhode Island, a bunch of species showed up that we don't have, and that's great. And we can talk about how to include those, and I've actually folded those into the regional species list now, and so we can talk about sort of the protocol for how to do that. But the idea here is every meter, look at one point on either side of the transect, So that's 80 total points. And then record the identity of all species under that point. So I noticed in some of them there was only one species, but the idea is count everything. So we typically find that there'll be 3 to 4 species under each point. The idea is to actually get at that layering. We're not explicitly recording layering, but if you go down, you're like, okay, here's kelp, and there's a red under it, and there's a coralline under that, record all 3. Yeah. So the idea here is to get the percent cover of all species. Another thing that we're doing this year is trying to match up percent cover to biomass. So this was something that Shannon Harrer did over at the Santa Barbara LTER. She actually put together some methods for turning point counts into grams dried carbon. So we're going to try and start doing that here in New England. So that way we have some common currency of some of these.
Is Shannon joining us?
No, I mean, she's still working at SBC, so they're still doing the.
She's in Providence.
Shannon, really?
Yeah.
What's she doing in Providence?
Husband, boyfriend's at Brown.
Huh. I did not know she
We
moved.
need together.
Yeah. I haven't seen her in ages. That's great. Thank you for telling me that. Okay, but yeah, so Shannon did that original work when she was working on her master's. Awesome. But yeah, so this is an open list, and the last thing we record is substrate type, since that's important. And so we're using a common standard definition of different substrate types as well. Yeah, look at the data sheets in a second. The last thing is Kelp Morphometrics. So again, trying to find the right way to define kelp, and so we can turn all of these into biomass. How morphometrics are done are going to vary depending on the type of kelp you have. So each region, this is going to be a little bit different. In California, or in areas like Tasmania or parts of New Zealand that have macrocystis, there's a really nice protocol for just basically doing stipe counts at 1 meter. Other areas that have different types of canopy species, we need to figure out what those are, but it's going to be some sort of subtitle count. Here in New England, what we've been doing is just taking 10 pieces that are spaced sort of relatively evenly along a transect tape, bringing them back to the surface, measuring them, and then throwing them back. Or this summer, we're actually going to be drying some out so we can try and derive a morphometric measure. Again. So this is really just blade length, width, and stipe length. In terms of managing it, usually the divers that do the swath count and swim back, collect some pieces, bring it back, and whoever's your topsider can measure things when they're out of the water. So morphometrics. This afternoon, we're going to do a sort of basic practice so we can all make sure we're doing things the same way. I will also say, do not collect data your first day out with your team. We've put together sort of a practice data sheet for a 10-meter transect, so a shorter transect where you can do 1 quad, 1 swath, and 10 point counts. Everyone can try it out. You can look at the relative abilities of different divers. You can also begin to compare species IDs and make sure that different divers within your team are all doing things the same way, all identifying things the same way, all counting things the same way. Also, at the end of doing this, we typically find that the first dive, there are always a ton of questions. Oh, I saw this. What is this? What is that? How do I count things this way or that way or the other? I cannot emphasize enough how important this is to do on day one. Again, just to get everybody familiar so that the first transect you do isn't about figuring out what you're doing. It's about already feeling at least somewhat, I mean, there'll always be more questions that come up. It's about feeling at least somewhat comfortable. Starting to figure out what the species codes are, starting to have to look at things less. So I would recommend every team. We're going to be doing this on Tuesday, I think, up in Salem. And I'm happy to sort of talk more about that or one of us to come down while you guys are doing it. Be great. All right, before I talk about data management, let's actually take this as an opportunity to take a look at some of these data sheets. So we can, if there are any questions about what's on it, how do I count it, et cetera, we can go over that. First, any questions now? Actually, general questions. I can't actually see the online chat, so I don't know if any of you online have questions. But I'm going to stop screen sharing. Hello again. And I'm actually going to pull up our data sheet. So there is a GitHub repository that is linked to from the the Keen website. So if you go to Materials and Methods for the Keen website, it'll link you to a repository that I update from time to time as we change things with all of the data sheets and all of the data entry stuff. So the repository will give you an archive that looks kind of like this. So let's take a look at a couple of things. First off, actually, I'll show you our species guide. So one thing we produced, I'll screen share this. Is a species guide. And so all of the species that we have species codes. And so within this is sort of a PowerPoint that you can print out onto some waterproof paper and take out into the field of just all of the species that we include in sampling so far. We found this really invaluable, again, as our what's that. There are a number of really good species guides for New England subtitle species as well. You know, there's Andy Martinez and others. But we ended up realizing that the taxonomic coverage was insufficient for what we were doing. And so a couple of years ago, Katie Bland, who's now up at Shoals, put this guide together. So it's part of the archive. You're welcome to download it, print it out. If there are questions, comments, things that should be changed, typos, I guarantee you there are typos. Those are likely my fault. Let's add them. We have a file that now we're maintaining, and we just update this as we go along. So for example, the Rhode Island species, let's take a look. I actually have those noted, and we can take a look at those and add them to this guide. You'll notice that everything, actually, there's a great place to point it out. Everything has a 4-letter code or 3 or 4-letter code. That's for data sheets because you're not going to write out a full species name underwater if you even remember it. Generally, if you forget what a species code is, it's usually the first 2 letters of its genera and the first 2 letters of its species. So Halosyphon tomentosus is Hato. Some of them are shorter for more common things. So Saccharina latissima is just SL. Some of them, the taxonomy's changed a little bit, but we're keeping the species code for consistency. So Heterosiphonia japonica is now Dasyphonia japonica, but the code is still HJ. If we're going to change that, we should all agree on that. It hasn't happened yet because that's going to be a big data management headache. But if we feel strongly about changing that, or someone within the network feels strongly about changing codes, we can do that eventually. And just to reassure you, all taxonomy at the end of data collection is standardized using the World Registry of Marine Species. So even if you have the wrong species name, it'll go into worms, and worms will kick out the right species name for the actual data set itself. Okay, so there's that. If you want to know what the species are, if you just want a handy-dandy list, we maintain a constantly updated species list. So every region should have one of these. Let me blow this up a little bit. So regional coordinators, first task is to build a species list. Within the species list, we have kingdom, division, family, and a common division name. The common division name is actually the one thing that's really shared across all regions. So something like green algae is green algae is green algae. And then species code, species name, some information about the size, because we do split some things into juveniles and adults. Some distinctive traits, which we usually put onto the data sheets to help people ID in the field, common name, and then what protocols is it sampled in. This is really a reference and something you can go back to. It's also used in quality control checking to make sure that all of the right species names are in. And what I've been slowly doing is actually putting data validation into the data entry forms that reference this, so that this is also what's validating all of your data. So hopefully you can't enter an incorrect species code, hopefully. I also have a notes column, and you'll see, for example, I've put in some of the Rhode Island species that we did not have previously. So as we add new species, we'll put them in. This and many other things have a change log, so you can actually see what's changed over time. So anytime you worry, hey, I don't know if I'm working with the most current list. I know I emailed Jared about changing this. Just check the change log, and you can see if it's a change that's been made. So there is some Excel version control, if you can call it that. But because this is all maintained on GitHub, there's also a formal version control log for those of you data nerds that really worry about version control. I do, but that's me. All right, so let's look at the actual monitoring data set sheets, because that's where I think a lot of people sometimes have questions. Because this is what you'll be using. So first off, this has a change log as well, so you can see what changes have happened over time. The most recent one, for example, is I added a no fish code. People were recording, sometimes sites have no fish in the fish survey, and people are doing really different things on their data sheets if there were no fish, which made coordinating that data kind of a small nightmare. Because I didn't actually know. Was it there was 0 fish? Was it that a data sheet was missing? Was it that something was, yeah. So now there's just a formal no fish code. But again, change log, you can always make sure that you have the most current up-to-date data sheet. You can see even from 2016, there are 4 different changes that I made to this. So as you're out in the field, as your group is out in the field, there's something they notice with the data sheet that's problematic that they want changed. Or something that's missing. So for example, the Rhode Island group needs some changes. We can start to make like a Rhode Island specific data sheet. Let me know, and we'll both add this in here as well as include something in the change log. So here are the data sheets that each group will work with. First, we have just the site log. So every site, we need some relevant information about it. So when you're at a site, every site needs to get this information. So here we have 4 transects. I've simply named them transect 1 through 4. We also have some areas that the transects have specific names because they're associated with specific features. Whatever works. 1 through 4 is usually just fine. So we have our date sampled, the start latitude and longitude, and end latitude and longitude. Some groups have actually asked, how do we do that? And we simply pop a float at the end of our transect line, and then as we go and pick it up and record the GPS coordinates. A start and end depth. And you'll see on other data sheets, there are places where that gets recorded. Visibility in meters, if we need to begin to think about correcting for visibility in some analyses. The temperature, which, that's going to be a simple daily snapshot, but useful to have. I've included a line for waypoint name for groups that are taking boats out and recording waypoints. We've just found that's really useful so we can find things again the next year. And then notes. As an example of a change, I'm probably going to put a checklist in here as well to make sure that all of the data sheets have been seen and accounted for. We found sometimes that a data sheet would end up loose on the boat, but I'm going to put in some more organizational stuff here just to make sure that everybody keeps their materials together. But I will email the entire group once that's done. That's site info, pretty basic. A second sheet for loggers, and I split this into a second sheet because sometimes loggers are dealt with at a different time as other information. But just the waypoint name, the date that you're either deploying or retrieving a logger, whatever unique identifying information you have for that logger, so a number. And as you can see, actually in the data that you send to me, 1 year it'll be a logger goes out, the next year it'll be retrieved. And so I match that up to derive the history of a logger. The samples per hour that you set it to, so what's the frequency, and what's the latitude and longitude where you deploy it. So again, this is so we can actually locate where every logger is on the seafloor. And then notes. Okay, questions about that? It's very straightforward. All right, so point counts. This is our point count data sheet, and I want to walk you through it a little bit. You can see we've got standard information, what site, what transect, what's the date, who's the observer, who's actually doing the work, what's your depth at 0 and 40 meters, and what's the visibility. So that's where we get some of the information for the site sheet. You'll notice we have things like that on multiple sheets, and that's just to make sure that at least somebody records that information. Yeah, Brecky.
Just to clarify, people get confused when we ask what the depth is at 0 meters. That's where you start your transection on. 0 meters is the depth of 0 meters.
Yes, good point. So for those who could hear, Brecky was noting that depth at 0 meters doesn't mean how deep is it at 0 meters, but at the start of your transect. You'll also notice around the edges of these, we have some stuff like scanned by, date scanned. At the bottom, we have entered by and checked by. I'll talk about that in a bit, but again, this is all just about establishing a good chain of custody for each data sheet. There are times where we have gone and found that person and asked them a question about what's going on at that point. This is sort of each point has a big, broad field. And the idea is that you can write, even me with my large and absolutely unreadable handwriting, and I'm so sorry to anyone that's ever had to translate it, can fit 4 or 5 different species codes in here. I think there's maybe been one point I've found that had 6 in it. But usually it's somewhere between 3 and 4. And then an area for substrate. So you can see we have all of our substrate codes up here. So we have pebbles, cobbles, boulders, and there are size definitions around each. And then we go into the species. So you know, the nice thing about working in New England, and this may, again, not be true as we go south of the Cape, is that we have few enough species that we could fit all of the codes on one sheet. If it becomes necessary, we can also pop this out into a separate sheet. When I worked in Santa Barbara, we had actually a whole separate sheet of just species codes for point counts because there were twice as many species. So yay, low diversity. But again, we've split things into categories, so it's fairly easy to search and then alphabetized within that, so if you roughly know what you're looking for. And each of these has just both the species name and often a note about, let me blow this view up a little bit. It is blown up. There we go. And often a note, so you know, Ceramium spa, it has pincers and is corticated, something like that. So just a little note. Again, these can all be changed. There may be things that different divers find helpful as their notes. You'll notice there are also these unidentified categories, so URB for unidentified red blade or unidentified filamentous red. These are for if, yes, I don't know what it is. If you do know what it is and it's a species we're not currently recording, note it, and then when you get back on land, we can add it to our species database and add it to the data sheet. And like I said, we have not yet had to make site-specific data sheets, but I think as we expand out, particularly to Rhode Island, and if we end up adding Long Island, we're going to have to do that, and that's great. That's totally fine. Coordination will be a little, there are certain things that I'm going to guess you're not going to see ever because they're more Arctic species, and certain things you will see that we don't here. And that's fine. Just want the easiest, most user-friendly data sheet possible. So for example, we don't really have corals on here, and yet I know you guys see some. Yeah, yeah, and so.
We also see the Zuzandelli, the colored.
Oh, cool. Yeah, so again, that's information that we want on here. We should add that. And there's a little bit of space left. Cram it in. All right, questions about point counts in those sheets? Isaac? Okay. Questions from the peanut gallery? No? Quadrats. So the quadrat sheet, we actually have a number of species codes already included. Those are based on the things that we have seen most commonly in our quads over the years. That you're not guaranteed, but you're probably going to count these at some point. So at the top, we have a couple of the algae. So here we've got Saccharina latissima, Saccharina latissima juveniles, and just blades. Desmarestia viridis, which we see pretty commonly, agarum, Desmarestia culeata, and those are the most common algae that we count in these quads. There are others, and you can always add them down at the bottom, but that's what we primarily see. Here we've got our 2 crabs, Cancer borealis and Cancer iratus. We have both Homarus americanus, so large lobsters, and then Hoasses for smaller ones. So the thing about this, here we've got a bunch of stars. You notice that down below, we actually specify some size cutoff. So for example, for urchins, there's SDL and SDS. And so that's so we can start to get a sense of adults versus juveniles. And there's a size cutoff. So we have a 20 millimeter size cutoff. And if they're smaller than 20 millimeters, it's an SDS. If it's larger, then SDL. There aren't many species we do this for, but there are some species who want to start to get a sense of recruitment. So for example, urchins, what's been kind of crazy is the sites we've been surveying, we see very few, but we see big pulses of juveniles every year. And that's something we're really interested in tracking. For sea stars, which you'll see there's a split there as well, we've been seeing nobody. And then suddenly we saw a lot of little guys. And this year I'm very curious if we're going to start to see adults. So there are a few of these that juveniles are relevant. And typically it's usually just the species code. And either the last letter is changed to S or you add an S to it. Just take a look at the list and you'll see. We do include some cryptic fish here. We're going to talk a lot more about this at Species IDs tomorrow. So John Grabowski is going to do the fish lecture. And hopefully, Ted, are you going to be here tomorrow as well? Ted's done a lot of this, so he'll fill us in a little bit more on some of the decisions we've made there. We do a lot of lumping of little guys because they're hard. Yeah, you just can't tell them apart. So that's quads. Questions about quads in the data sheets?
Jared, for quads, you want us overturning rocks?
No. No, the idea is to be look under things, but not like destroy, put it back together.
On that note, one of the things I've done is I bring a flashlight now.
Oh, that's good.
And it makes some huge differences to what I consider.
Especially cryptic fish.
Yeah, flashlights can be really helpful.
Also, Ted does this like pat thing for a lot of the more camouflaged fish. If you just kind of pat around like
So as we do the quad, I'll sort of like, especially through heterosophonia, I'll just kind of run my hand, sort of just particularly my fingers along, and they'll sort of dart out, or just
so
move,
things that were
or they'll
like
just
hidden.
move ahead a little bit.
Yeah.
That's a good idea.
Yeah, filamentous
Instead of just,
shreds.
like, eyeball, yeah.
Some of the, I'm not sure how it is in your sites, but we got some areas, particularly out at shoals, that are just carpets. Like they're just shag carpets of heterosophonia. Yeah. And so you really have to kind of look in there a little bit. Swaths you'll see are really similar. Again, it's inshore, offshore, and marked what segment you're on, so that's pre-marked. We also have a couple of things that are really common. So honestly, I think swaths are really where we get our best crab and lobster data, definitely the best lobster data. So we'll do that analysis eventually. And we may kick lobsters out of the quads entirely and might make them swath only.
You need to go looking.
What?
You need to be looking.
Yeah.
The crevice with the light.
Yeah. But otherwise, it's broadly the same. There's a slightly different species list. So here's really where we're getting cnidarians, because they, again, in the sites we've been working on, they tend to be less common. This is also where we've been picking up more stars, just because they're rare lately. And there's a larger demersal fish list, again, because these are slightly larger, a little bit rarer. You'll notice we've got 2 brown algae on here, and those are clumped. They're pretty clumped species that we were missing in quadrats, but you will see periodically. Super similar to quads. Swaths are also a good one if you have new students. Quads and swaths are basically the places that they end up. While it may look like a big species list, it's functionally not that big. You pick up the common things pretty quickly. And then the rarer things, you'll tend to start to get a sense of, oh, that was something really different. Come back to the boat, look at a species list or a guide, and then you're on your way. Yeah, Isaac.
That was a question.
Yeah.
I don't know when it went up.
See if I can pull that up. I don't think I have the chat anymore. Ah, there it is. Oh, where are the UP? Okay, great question. So Aaron's asking where are the UPC points laid relative to the 40-meter line. The UPC points, typically we bring out a meter-long piece of PVC. or meter stick, and then just lay it right on top of the transect line, so half a meter on either side. You'll see like the diver doing UPCs will just kind of bumble down the line. So I would try and have the UPC diver go last because they probably stir up the most stuff because they're like just all over that area. And so they kind of go down and flip back and forth on either side. Second question, is there a maximum number of organisms counted on swaths? No, I don't think. We've had some dives where there are some really common things, but the point of swaths is generally for things that are rare enough that they can't be counted well by quads. If you have something that is so common that you're not able to count it because it's functionally infinity in your swaths, it's probably something that should be moved to quads. And that's something that you should talk to your regional coordinator about the decisions made there. For those of you who are working on the West Coast, right now what we have is a species ID guide and set of species codes that we've pretty much, so hundreds of purple urchins. And that's why urchins are in quads, because otherwise you would shoot yourself. I've done those quads. I still wanted to shoot myself. So yeah, that's a quad species. That's definitely not a swath species. Great, good question. I think I can pull this out to the side now. Great. Okay, I'll blow my nose real quick. All right. Fish. So the fish data set is pretty different from these previous two. Sure, again, let's view it a little larger. So fish, because New England is pretty fish depauperate, it's obviously going to be a little bit richer where you are. Again, we have the fish that are most common that we see. These are pretty much all the fish we see. Maybe we see a few others. Each one has a row, and then we've got just counts for number in each size bin. These will typically be hash marks that get totaled up, or just count them depending on what your transect is like. Again, you've got depths, visibility, temperatures, etc. We do have additional codes at the bottom, and we'll talk tomorrow more about what fish we have included and why, and whether there are some we should include. This is a pretty good list, I think, that covers from down east down to at least Rhode Island. We worked with a couple of people to try and figure out what we might see south of the Cape. So you guys may end up customizing your sheets a little bit, but hopefully everything you need is already there. You'll also notice at the bottom, now it says, if there are no fish, enter 0 in the total column for no fish. So if you end up having no fish, under this no fish code, just under total, put 0. And that way, that's going to provide a single, consistent way that when you actually enter the data, we know that, yes, somebody did this transect and there was 0 fish on it. So that will help. Yeah, it was a good day of like, what is going on with this data? And then I went through the scans and realized everybody did it a little bit differently. Last is kelp morphology. And so here it even says, collect 1 kelp of each species every 4 meters for a total of 10 pieces. Again, this is for sub-canopy species. Don't try and do this with Macrocystis if you're working where that's present. So here we've got agarum, alaria, laminaria, digitata, and saccharina latissima. So just bring back 10 species. If a particular species isn't present at the site, it's fine. Don't bring any back. You can't bring back what you don't have. The idea is to get 1 every 4 meters, so the piece that is closest to that mark on the transect tape, so it's at least a sort of semi-stratified, not biased way or unbiased way of getting those pieces to build a size distribution. There's also a note here about how to measure laminaria digitata that can sometimes be tricky since it can get quite wide. But it's simply just record the blade length, width, widest width, and the stipe length. You'll notice we've got transect here, and that's because we often find that if you're out doing a couple of transects, you'll often have a few transects on one sheet because it's 10 pieces, then another 10.
So this one's really simple, but for some reason I always screw it up.
Yeah.
So for a total of 10 pieces,
Yes.
that means that if you have super diverse area,
Yep.
and you get one of each of those 4 in your first 4 meters, and then one of each of those 4 in your next 4 meters, you only want to collect whatever the next 2 are that you see. So you
10 pieces of each species.
got it. Okay.
And I can change, collect one, yeah, let's see, collect 1 kelp of each species every 4 meters of 10 pieces per species. And I'll push that to GitHub later tonight,
Okay.
so it'll be up there. Good question. No, that's a good clarification. Because you're right, there are some dives where I'd be like, why do we only have 3 garum?
Yeah.
Other questions about this? Aaron, for you and anyone else who's doing giant kelp, there's a slightly different protocol for that. It's in the handbook. We have not talked about things like, Eulalia up in Alaska, or if anyone ends up doing this in South Africa. But I'll leave that to the regional coordinator to decide the best way to get those morphometrics. All right. And then the last sheet we have is the training sheet. And so this is for that first 10-meter training dive. And you can see it's 1 quad, 1 swath, which is a short swath, a couple of point counts. It's an abbreviated species list. We've got the sort of quad swath stuff down here. Actually, I haven't updated it in a bit, so maybe there's some things that are not quite right, but it's a training dive. And then if you want a sort of full species list, there's a second sheet. So if you just bring one of these, you should be good to go. And again, we'll talk a lot more about species and species IDs tomorrow. All right. Other questions? Any other questions about the actual physical sampling? Good. All right. Yes, I do.
Sure, I'm gonna go to that meeting.
Yep, good. All right, so the last thing that we're going to talk about before we break for lunch. Let me go back to this. Okay. So I want to talk just a little bit about data management and collaboration to round it out. So you've gone out, you've done your survey, or you've done your experiment, and it's time to wrap things up. What do you do afterwards? And this seems like sort of a facetious thing, but there's a surprising amount of places where things can go wrong. And so I wanted to go over this briefly. So again, so that we're all doing things in the same way, we all trust each other's data sets, and we all kind of feel good about what's going on there, and lay out some things. So first off, there is an infrastructure for data. So if you go to kelpecosystems.org, projects, project materials, all of the information is there. So again, that same sort of link before, all of the sort of how to enter data, et cetera, templates for data entry, they're all there. And the idea is that we're collecting data in the field in a standardized manner, that we're entering it using the same format, and then ultimately the data is curated in a central archive. So ultimately, first data will go up on GitHub, and so there's a repository you can see right now with all of our data cleaning scripts for your raw data. And then temperate reef base is the long-term destination for all of this data. So from now on into infinity, you'll be able to go to temperate reef base and actually get access to the data. As just sort of a data management workflow, once you, yeah, question. Can I describe the standard order for each data collector? Yeah. So actually, that's a good point. Before I talk about management, here's how, so there's a section on this in the handbook, but here's how we do our team monitoring dives. So we typically have teams of 4 divers that go down. The first buddy pair gets in the water. The person swimming out the transect tape does the actual fish counts. They stop. They turn around and with their buddies swim back and do swaths. And then when they finish with swaths, they turn around and they collect all of the kelp for morphometrics. The second buddy pair waits about 15 minutes or so until the fish count is probably done, gets in the water, and usually in the second buddy pair, one person is doing point counts and the second person is doing quadrats. And so they will usually roughly keep pace with each other so that they stay in a second buddy pair. Sometimes we'll have the quadrat person actually bring a UPC sheet as well, so that if they finish all of their quadrats at 40 meters, they can turn around and do a couple of points on the way back. And then when they get back on the surface, add those points to the other person's data sheet. So there's only one UPC data sheet. And that's it. That seems to get it all done. I think I've only run into one transect where with 4 divers, it's taken more than one dive to get it all done. We can typically, with 4, you should 1 dive, 1 transect. And so if you plan for a 2-dive day, 2 days to get your transects done, and then an extra day to put down temp loggers if you don't do it one of those 2 days. So we can typically, if we're like really, really good, get it all done in 3 days. That doesn't always happen. That's sometimes a pipe dream. I can see Brecky laughing at me right now. Most of the places that we go, we typically have 2 sites, and so that'll usually take us about a week. Sometimes, plus or minus a day. When we go to shoals, we push really hard. We have 3 sites there, and we usually get done within 5 to 6 days, weather depending. So, cool, great. Once you get back to the boat, actually I said scan sheets within dry, but really once you get back to the boat, the first thing you should do is pass those sheets around and make sure that everybody can read everybody else's handwriting. Make sure that any hash marks you have been totaled up so that there's an actual number written down, because sometimes, who knows, is that a 2 or is that an 11? I don't know. So go around, check them, and then put them in the holy and sacred completed data sheets folder. Yeah, Nelson.
We've also just taken pictures on the boat.
Okay.
In case.
Yeah. Yeah, that's not really, we haven't really standardized that yet, but I think if we do that, I know I've got like a bunch of if you do that.
That's more in case the whole holder goes missing.
Which has happened.
Use a slate on the next dive.
Yeah. I would actually recommend, because we have done that for 2 years now, but it's been really scattershot. I would actually recommend that we take out a single camera dedicated to that. So like we have our lab camera, and as long as we keep that on the boat and photograph things afterwards, that way it's on one camera on one escape. What? Okay, we can talk about that later. But if your lab is planning on photographing in the field, I would recommend not splitting it up amongst multiple people's phones. Have a single camera dedicated to taking photos of data sheets so it's all in one place. And that'll minimize confusion. Basically, all of the steps I'm going to talk about from now forward are about minimizing confusion and minimizing places of loss and mistakes, which, again, sounds trivial. But when you're dealing with even a single lab managing one site with 4 transects, it's amazing how quickly even that can, like one small thing can cause that to spin out. And since we're a network and there are a lot of us and we're all doing 1 site, 2 sites, 3 sites, etc., I want to make sure that we're all doing this in the same way so that we all have high confidence in what we're doing. So in addition to any cameras photographing and checking that you do on the boat, get back, rinse your sheets, and the first thing you should do is scan them once dry. And then print the scanned sheets. Once you scan in your originals, archive them, and hopefully you should never have to touch them again, except to mark that they've been entered. And the reason for that is twofold. One, it makes sure that those originals will exist and no one will accidentally lose them during the data entry process, which I've seen happen. And 2, if you print out a scanned sheet and can't read it, that means your scan isn't that good and you should rescan the sheet. So it forces you to make sure that the quality of your scan is good enough that you will always be able to go back to it. And I will say, again, having dealt with all of your all the different groups' data sheets, those scans were invaluable. So I have used some of your scans to actually check and solve data errors. And because they were readable as a PDF, that saved me a ton of time and in emailing and asking questions. So absolutely essential. And then enter the data from those scan sheets. So from that point forward, you should always be working off of the scan. So enter the data. There's some standard data entry forms, and we'll take a look at those in a minute. After the data is entered, note any questions for each data sheet. So I guarantee you when you enter data, or the students in your lab are entering data, they'll flag a bunch of questions. Data should be entered, and then questions should be noted. Answer the questions during the QA/QC process. So QA is quality control is really important here. Again, we're human. Typos happen. I'm doing as much as I can to make sure that the data entry templates don't allow for typos, or at least minimize them, but they'll happen. And so really what I'd recommend for a QA/QC is the read it back method. So get a pair of people or record yourself reading a data sheet, and then just go over and read it back and make sure that everything matches. It's a bit of a pain in the ass, but get like a soundtrack going, something. And you will catch errors. You will catch more errors than you would care to catch, but you'll see they're there. And that read it back method is it's kind of the best way. Until we can figure out a way, actually I saw a library in R that might let you do this, and so I'm sure I'll mess with it, that lets you scan it in and then feed the scan in and then turns it into a nice Excel table directly within R. Until we hit that magic moment, physically enter it, QA/QC it. And when we hit the magic moment, I will be the first to embrace the singularity. There is a chain of custody log. And so at every stage, note in the data log, as well as on the original sheet, what has happened. So again, keep the chain of custody going. We have had data sheets go missing before, and it was because of that chain of custody that we were able to go back and find out who had the data sheet. And so they were able to go and find it in their file drawer where they'd forgotten it. Again, shit happens. So make sure that you at least know where the shit happened. And at last, once everything is entered, it's been QA/QC'd, you've got all of your scans, zip it up it'll all end up going to one final folder, zip that up into an archive, and send it to me. And I've written a number of scripts that do additional error checking when it attempts to merge your data, and generates both error logs as well as sometimes it just dies. And I will ask you about that. So for example, that's when I noticed the difference in UPCs this year. I've noticed actually some of our sites, there were a couple of points that weren't entered, so I was getting weird point counts. And so I had to go back to original data sheets and found that when two people entered different data, things happened. All of that will pop out in this automated error checking, and I'll turn things around and ask you about it. So I found the new species codes and was like, oh, that's great. Put it in. Now we have new species. Sounds good. So we'll do the final round of QA/QC, and as long as it works, it'll get merged into the main data set and shoved off into the cloud. If you're really interested in this, you can go to the Kelp Ecosystems GitHub site. Again, this is going to be linked off of the Keen website, so you need to memorize URLs. But if you go to the observational data set, you'll see everything that's being done. So we've got all the R scripts that are the data cleaning scripts, all of the clean data, the errors that they're currently throwing, and there are still a couple of errors that I'm trying to track down before this gets finalized in temperate reef base, as well as both the raw data, species list, and derived data. For those of you, as a side note, who are interested in doing standardized taxonomies for other data sets, so we actually use this for our marsh data as well. One of these scripts takes the species list and runs it through worms and generates the current up-to-date taxonomy. So that's been really useful across multiple projects, so feel free to reuse that. It uses the taxize SOAP library from ROpenSci, because all good things come from ROpenSci. All right. Yeah, and again, the final repository for this is going to be temperate reef base. The current data set isn't there yet. That's because I'm tracking down the last couple of bugs. But once it is, it'll be pushed there. Every site so we've in the sort of data sharing discussions we've had, every site wants a citation for their own data set, which is great. So we'll push it up there, and included along with it is citation information. So in the metadata, there will be citation information, so you can cite your data set in the future. We haven't really talked about how we're going to update those citations as we go forward from year to year, but that's a discussion we'll have next year, once we actually even get it there in the first place. And this is just to kind of show you, I showed this slide yesterday. This is the kind of stuff we can get out of it. So here's a plot of all of the different sites we have in the database so far, and we've got both percent cover and number per square meter of Saccharina latissima. And you can see they're kind of different, and I think that's interesting, and we can begin to start to derive some information about individual abundance versus percent cover. The two things do mean very different things in terms of what they're telling us. But here you can just see already with the sort of 3 years of data that are in there, and with, you can see Fort Weatherall creeping in there right at the very end with a single data point. We can start to begin to understand and start to look at patterns and trends. For those of you, again, who are really interested in the data that's there so far, check out yesterday's Google Hangout, or I'll even be posting the demo script that I used to generate all of the slides from yesterday in the GitHub repo as the README, so you can take a look at that shortly. At kelpecosystems.org, we do have a member, I call it the packet. The packet includes a bunch of things. It includes actually a Word document that has all of the protocols written out for you, as well as all of the regional variations. So we still need to add a few more, but each coordinator has been writing up any regional variations in the protocols that's specific to their region. That's all in the handbook. It's also going to get updated once we finalize this new removal idea. The packet also has all of the data sheets. So I walked you through the New England data sheet. It's the only one we have right now. But there's also a generic set of data sheets so that you can modify those for your own use. I think we might actually also have the Santa Barbara coastal data sheets for those of you on the West Coast that want to adapt that to your site. There's a visual species ID guide for every region. So we ask regional coordinators to put together that visual ID guide. And then all of the standard data entry forms. Just to sort of wrap up and talk about data sharing. Data, one of the agreements that we've sort of all signed on to is that all data is open within the network. So either in public or private. So experimental data we'll probably keep in a private GitHub repository until it's published, at which point it will go up to temperate reef base. So all experimental data is open within the network, but is fully open after it's first used for a publication. Well, that's experimental data. Or other data sets. So for example, the Kelp Time database in the from Hansel et al. Paper, that is now fully open. We've pushed that out to the public. All data and code is available. The observational data that we're collecting now, we went back and forth on this, but really the idea is that it's open outside of the network immediately. So once you've taken your observational data, it's reported. And that's because we're really interested, if management agencies want to use it, we want to be providing the most up-to-date data that we can. It is all CC BY, so that means we request that if your data is used before it's been published in an academic publication, that whoever is using it requests that you collaborate with them. So there's that, so you do get collaboration benefits. And second, because it's CC BY, the data cannot be used without being cited. So your data products should always be cited, and your citation count should grow, and your professional standing should increase. And these are data products, so you can include them on things like grant applications, et cetera, as part of your CV. But the idea really is that once your data is in and it's quality controlled, it's open, so that we can all benefit from it, as well as anyone doing kelp forest ecology. And yeah, so the idea really is that individual scholars, their observational data is cited. And just to sort of wrap up on my evangelization soapbox, all of this is about collaboration within the kelper community. Really, the reason that we put this together is at NCEAS, we realized we needed this, that we don't have a large standardized way of looking at kelp forests. Everybody has different ideas about how the forest works in their backyard, And one of the barriers was that we were all looking at our systems a little bit differently. The hope is that when we all start looking through at least similarly focused lenses, we can begin to understand the generality underlying those differences. And so this really is about collaboration. Again, just to sort of reiterate authorship, because this comes up a lot, that for the first publication, if you have contributed data, you are on there as a co-author. If you are a keen collaborator, you've contributed data, you have earned authorship on the first time that data is used. For subsequent contributions, the idea is that you request collaboration within the network. So if I'm using somebody else's data, say, hey, would you like to join on? But by collaboration, I don't just mean, yeah, you can use my data. I mean, you need to be a substantial intellectual contributor to that piece. So there's no such thing as a free lunch, that you actually become a real contributor. That's something that right now we don't have any hard and fast rules about, but ethically, I think that's really important. NutNet's gone to a similar model. I think a lot of the experimental networks out there are using something very similar. And eventually at TRB, all of the data sets will have a DOI, so you will get citation and credit. For those of you in Keen 1 and in general, just to let you know what we're going to be doing here at UMass Boston, we will check all of your data for you once you send it to us for QA/QC. We will compare your data to regional species lists, make sure those match up. We have automated checks for outliers and incorrect values as well, and we will bounce those back to you unless we can resolve it first by looking at your original scan data sheets, which again, I did. A bunch of outliers. It was right there in the scan data sheet. And then merge that data. So think of us as your data managers, really. All right, that's it. We can take a look at the data entry forms just to see if there are any questions, although it should be pretty self-explanatory. But now that we've been through all of this is sort of all of the background grounding you need. We'll practice the monitoring protocols this afternoon just so you can get a sense of what they're like. But yeah, get out there and count some kelp. That's it. So I'll pause right here and see if there are any questions. I think we're back live.
I
Yeah.
wonder if we should grab a GoPro and film our practice session to show Aaron and the other people who are watching.
Yeah, sure, we can do that. We'll film some of the afternoon practice sessions so you can see what we're doing.
Because those are remarkably helpful.
Yeah, that's a great idea. Yeah, anything else? All right, really quickly. So again, this is sort of the structure of the archive that you get from GitHub. I'm actually going to share this. Screen sharing. So just to point out, this is what we have in terms of the data entry infrastructure. So we have both observational sampling and removal experiment. You notice the first thing we have is a chain of custody log. And in that chain of custody log, I'll close this. We have everything from experiment, site, year, month, day, protocol, as well as additional information. So every time something happens for a particular transect's data sheet, it gets recorded here. And over time, this should be filled up until it's checked. And once something is checked, then it's done. Within the observational sampling sheet are the yeah, Aaron, we'll talk about that in just a second. That's a great question. So within this, you can see we have a folder for scan data sheets. So as you scan them in, put them in here. We have data entry in progress, data templates for entry, data to be verified, and verified data, as well as a little file about the data entry process. So essentially, when you enter data for a new site, grab the right template. So here we have all of our templates. So grab the template that's relevant for the data file you're working on. copy it, plop it into the data entry in progress, and rename it with the site name included along with the template name. So Fort Weatherall UPC 2016. Work on that in the data entry, and once data entry is complete, move it over to the data to be verified. And then whoever's taking over on QA/QC, work from there. In the data to be verified, that's where you do the read one back QA/QC, as well as ask any questions of whatever diver you need to track down who had unintelligible handwriting. That diver will probably be me. I'm sorry. After a data sheet goes through its QA/QC process, and you've answered all of those questions, move it into verified data, and it's done. And you'll see in the chain of custody log, all of that is there. Usually we try and do all of the data entry first, get everything into the data to be verified, and then do all of the QA/QC and move it. So it's sort of a multi-step process. Unless you're the person who's entering it and you have questions immediately and you want to run down the hallway and yell at me for having terrible handwriting. Let's take a look at one of these templates just so you can kind of get a brief sense of it. So we'll look at quads. So the templates are a little bit different than the data sheets. They don't entirely follow the same format, so they're not nice and square. They're really set up so that they're immediately and easily machine-readable formats. So here we have year, month, day, as well as date. Date's actually a holdover. I may end up deleting that anyway, and that's because some people write month, day, year. Some people write day, month, year. Some people write something else entirely. And Excel is well known to destroy dates. And so having a year, month, day column is really the only way to make sure that dates are OK. We have cite and transect, and so largely when you enter things, you'll enter that once and drag it down, although make sure you're not adding numbers to your transects. Species code, and I'll just point out right here, you'll notice there's a tab on the side. And that tab goes to these allowed codes. And so there's data verification in here. And then numbers for quad 0 off, on, 16 off, 24 on, 32 off, 40 on. And so that actually does match so this roughly matches the structure of the data sheet, which you'll remember there's one quad per column. And so that allows whoever's entering the data to just read across a row. And then other things like the observer, any notes, who entered it, who checked it, and then some of that depth, visibility, and temperature information. The verification, those of you who haven't used data verification in Excel, it's really important. For species codes, right now, it's just a warning rather than a die, and that's because sometimes you have new species codes, though those should be changed later to something that's recognizable. But I've tried to implement as much data verification on these sheets as possible so that the right things are entered. Just data entry. I know it's pretty boring, but shockingly important. Or not shockingly, for anyone who's ever worked with badly entered data. All right, any questions other than Aaron's current question? OK, so the last question we have, and then I think we'll probably take a lunch break and say goodbye to everybody on Google, is are there people in the room or people online who have experience with using a scientific diving class as a mechanism for collecting data? So I can share our experiences and get some others from the room. We run a scientific diving class here at UMass Boston every year. And we've also partnered with a scientific diving class at Salem State. What we've done in the past is, as part of the class, had people learn something about the quad or swath sampling or learn some of the species IDs. And then I'm trying to think of how we structured the teams. Usually either two experienced, like grad student, tech, or PI divers, and then two students, more or less, at least so that teams always have one experienced and one student diver on them. And then we've put them into either quads or swaths and had them take that for the whole sampling. So we'll have a boat go out and say have 2 experienced divers and 2 students, or maybe 3 experienced divers and 1 student. Right now we have a new cohort of students coming through, and so we're putting together the sign up to have those students come out as well. But then those students are able to use the data for their classes as well as having access to past data. So hopefully that past data can be useful to them also. But yeah, having students as part of a class, scheduling that transect sampling. Our transect sampling right now isn't coordinated with the class. It's usually after the class, but I'm going to guess you could probably coordinate some of that. And we do have, we have at least 1 student here right now, and we've had 2 others pop through who are part of the class. And so coming to this in past years has been more formally part of the class. So it's great. We've had really good experiences using students, and those students have typically been doing quads or swaths. I'm sorry to everyone in the room that I'm talking. I feel like if I'm talking here, I'm also talking to you there. Other questions? Are we good? Awesome. Well, thanks everybody, and hopefully you found this useful. I'm going to shut down the broadcast. If you have additional questions about all of this, if you're from another Keen member node, you can throw something in the comments for the YouTube video. So thanks very much. Thanks to everybody. Let's go get some lunch.